Hi students, this is AJ sir. Let's study 9th standard ICSE Math, exercise 6A. Here in each question, two equations have been given in two variables. Now there are various methods to solve simultaneous equations, but here in the question they have asked us to use elimination by substitution method. So that's what I will teach you here. Cancel questions 1 and 2, they are too easy and of the same type. Mark the fourth sum and the 14th sum as IMP. The fourth sum has two equations in x and y. So first of all, we convert the decimal values into fractions. Take the LCM if required, but here it isn't. Get the common denominator, shift it to the RHS, and you get the equation. So now that's the usual format of the equation without any decimals and without any fraction. Get the value of either x or of y in terms of the other variable. That means shift every variable or number to the right hand side. I want y alone. I could have tried to get x alone as well. Now here I got the value of y as 250 minus 2x. That is equation number 1. Now the second given equation is again in decimal format, so convert it into a fraction, take the LCM, shift the denominator to the RHS, so you get the equation in the standard form. Here again we have x and y, two variables, two unknown variables. So we will substitute the value of y from equation 1. So here instead of y, I will substitute 250 minus 2x. So I get this. The reason why we are doing this is because now the entire equation has only one unknown variable, which is x. So now we can solve this and get the value of x. So open the brackets, get the equation. I want x alone. 20x plus 32x is 52x. Like terms together. Minus 4000 goes on the right hand side. Plus 4000 becomes 5200. 52 goes down. 0 remains. 52 ones are. X is equal to 100 is the value of x. Now use this value and substitute it in this equation 1. So by doing this, we can now get the value of y as well. So you see, we can find the values of both x and y using this method. First, we eliminate one of the variables by substitution method, get the value of the other variable, and substitute that to get the final answers. Now in the sixth sum, again they've given two equations, but the first equation, y is already alone, so that's easy now. What we'll do here is we'll call this as equation number 1. Now we'll start with the second equation, substitute the value of y with 4x minus 7. So now the whole equation is in the form of x. Only one unknown variable. Open the brackets, solve algebraically, get the value of x, which is 2.5. Substitute that value in equation 1 again, so we get the value of y as well. Now in the eighth sum, again two equations are given, they're in decimal. So the first thing we can do is get rid of the decimal. And I want y alone. So we get the first equation, y is equal to 62 minus 15x. This we will use to substitute in the next equation. The next equation is also in decimals. So here I'm going to just multiply the whole equation by 10 instead of doing the fractions first. So that's another way of converting it into an integer equation without any decimals. Now whenever you can reduce the equation further, we should. That makes calculations easier. I can see that this whole equation can be divided by 2. So I'll do that, so I get a simpler equation. Now we will substitute the value of y as 62 minus 15x. So the whole equation is in x. Open the brackets, like terms together. X value is 4. use this value in equation 1 again. Substitute it here so that we get the value of y as well. The next sum again has two equations, but there are fractions, so it's a bit complicated. Such sums should actually be solved in exam using the equalization of coefficient method, which is in exercise 6b. But here, since they have asked for the substitution method, let me show you how to do that. So first of all, since it's a fraction, let's take an LCM, which is into 3 here and into 7 for this fraction. So the denominators become same, that is 21, which can be shifted to the RHS. Take the like terms together, shift all the numbers on the RHS, and finally we get this equation in x and y. But I want x or y alone, so I'm going to shift everything to the RHS step by step. First shift 35y here and minus 35y, and then 6 goes down. So I get the value of x in terms of y, which I shall use in the next equation for substitution. Now the second equation is given, again the same thing, find the LCM, into 9 and into 2. The denominators are common, which are shifted to the RHS. Open the brackets, take the like terms together, and we get the equation in x and y. However, here the value of x shall be substituted. Since we found it, this value of x is substituted here. Open the brackets, multiplication will give you big numbers. Please do the calculations on your own, don't just copy. And then again LCM, so the common denominator 6 can be shifted to the RHS. Get the like terms together on one side and the numbers on the other side. I want y alone, send 993 down and do the division. You'll get the value of y as 6. And then substitute this value again in equation 1 so that you can get the value of x, which is 10. Now mark the 11th and the 12th sums. Cancel them because they are of the same type. 14th sum is IMP. So here again two equations, they are fractions. So first let's convert it into the usual format. We'll have to do LCM to bring the numerators together with the common denominator. The denominator is shifted to the RHS, so we get the standard equation. But I want either x or y alone. Here I choose to take y alone, no specific reason. So y is equal to 120 minus 5x upon 2. Let's call it equation 1. We shall use it for substitution in the next step. Again, this sum ideally should have been solved by equalization of coefficient method, which is pertaining to the B exercise. The equating coefficient method would have made this sum easier. Now the second equation is also given. Again, find the LCM, which is 12. So into 4. The numerators are together with the common denominator, which is shifted to the other side. We converted this into an improper fraction. Now here we shall substitute the value of y, which we had found out earlier on, so that the whole equation is in terms of x. Again LCM, so into 2 and into 2. So we have a common denominator 2, which can be shifted to the RHS. Like terms together, numbers on the other side. Solve and get the value of x. Now use this value in this equation here. Substitute the value of x to get the value of y.